Welcome to the Carboline Tech Service Podcast, the go-to industrial coatings podcast. Here are your hosts, Jack Walker and Paula Atzemis.
Be sure to hit like, subscribe, and set your notifications to on so you never miss any important YouTube content from Carboline. Welcome to another edition of the Carboline Tech Service Podcast. I'm Jack Walker. With me, as always, is Paul. Wait for it, Atzemis. And
there you go.
One of the things you might notice immediately about this episode is that we match. I guess getting on video means that we need to look more official, so now we have swag. If you want some Carboline Tech Service Podcast swag, sorry, they're rare. There's 2 in existence.
That's right.
I could get you a deal. But yeah, you'll see us looking a little bit more official from now on. So this week we're doing one of our usual guests. We have Brian Cheshire on, talking water, wastewater. And we're continuing on with our coverage of AWWA D102. If you remember a couple weeks ago, we talked about the outside coating systems. And this time we're going to talk about the inside coating systems. And hopefully Brian brings us a little bit more of a Godfather 2 type performance rather than a Teenage Mutant Ninja Turtles Secret of the Ooze type performance. So with that, we'll go to Brian, and here's our interview. Joining us today on the Carboline Tech Service Podcast is Brian Cheshire. He's our water, wastewater market manager. Hey, Brian, how's it going?
Hey, doing well, guys. Yeah, thank you for having me back on. I'm definitely excited to do part 2 today of D102. And I mean, who doesn't love a good sequel?
That seems
to be our specialty, though. We get on a theme and we just keep beating or feeding that fed horse over and over again.
The fed horse is definitely looking a little bit like Chris Farley these days. But we wanted to talk a little bit about the inside systems. Last time Brian was on, we talked about the exterior systems that were outlined as far as AWWA D102. So Brian, since we talked about that last time, can you give us a quick review of AWWA D102?
Yeah, sure thing, Jack. So if any of the listeners didn't catch the last one, we covered the first part of this in episode 177. But just some basic points I wanted to bring back up again. You know, talking about D102, it's a standard based around coating still water storage tanks. And the standard really lays out minimum requirements, but it's not a specification. So that's one misnomer, and I wanted to point that out again. You know, this, like a lot of the other AWWA standards, is going to have a lot of options that really must ultimately be evaluated and chosen by the owner. And that really feeds into today's conversation when we're talking about inside coating systems. There's 6 different ones, and different ones may be suitable in certain circumstances, but ultimately it's really up to the owner to decide those. And then, you know, lastly, kind of in a review for manufacturers, this really isn't a QPL or a product approval. Like I said, it lays out some pretty basic minimum standards or guidelines. And, you know, really covers, you know, an outline of methods and breaks down these coating systems that can be used for either new or rehabs of still water tanks.
So on that note, why don't we get into the breakdown of the interior, the inside coating system, sometimes called the ICS, as we look through this AWWA standard. Can you give us a little breakdown and briefly lay out some of the differences of these interior coating systems?
Yeah, sure thing. One thing, too, I wanted to point out on these systems is that they all have to meet NSF 61. And after January 1, 2023, they'll need to meet NSF 600. So I know we really dove deep into that subject in episode 138. Which honestly is kind of amazing that you guys have been putting up with me for that long. Well, what is that, 40-some episodes ago now?
Yeah, this is 181.
Oh, man.
Yeah.
Well, I've figured out you guys probably have me saying enough words now that you can probably piecemeal, you know, and edit me saying anything you want me to say. So I need to make sure I stay on your good side.
The thought is very tempting. Yes.
And as far as you know, we haven't done it yet.
As far as you know.
Yeah. But talking about the inside coating systems, or the the ICS as it's referenced in the standard, ICS-1, it's a two component epoxy system. And this is going to be a pretty basic system, very thin film. I mean, we're talking under 10 mils total. Mm-hmm. And then, kind of as you progress down, so ICS-2 would be similar materials, actually the same materials, but your thickness is going to be a little greater. And this one is a 3-coat, 2-component epoxy system. When you start getting into ICS 3 and 4, this is really when you start getting into, I would say, some of the more robust, thicker film materials. ICS 3 is, it can be applied direct to steel or over a primer, but it utilizes a high solids epoxy. They lay out a minimum of 96% solids, but we often see 100% solids epoxies used in this. And these are typically going to be at the lowest 20 to 25 mils, sometimes even greater. But keep in mind too, that's going to be dictated by the product's NSF rating. And kind of talking about ICS-4 being the other, I would say, pretty robust thick film system. This one's going to utilize an aromatic polyurethane or a polyurea hybrid. And this is going to be applied minimum of 25 mils, but often you're going to see these applied in even greater thicknesses. And really the last few, or the last two, 5 and 6, these are both going to utilize a zinc-rich primer. And then the difference between them is going to be the number of finish coats of epoxy over the top of it.
So one of the things that you pointed out there, Brian, that I think is really important is that we reiterate these parameters, this guideline that's given out by AWWA still needs to conform to your ANSI NSF standard 61 testing requirements. And if you go to those websites, whether it be NSF or UL, whoever the agency is that does the testing, because we've covered this before too, many agencies can do that testing. It is not just NSF that does testing. A lot of places do it. When you go there, they will give you the criteria of what is your maximum film thickness, frequently what's the minimum film thickness. So those are the application parameters for this guideline that's given out by AWWA. You have to conform to both if you're going with one of these systems.
And one of the things that I found very interesting, and I still find interesting, I've been in the industry for a really long time, and it still catches me, is that, when we talk about thick film coating systems, it's 20 mils. When you bring that into real life, that's like barely thicker than a business card. A business card's about 15 mils. So think about that we put a 3-coat system on to protect the interior of a tank, and it's about the thickness of a business card, and it performs great. And that's it is always kind of blown my mind, one of those small everyday kind of things that's a part of our industry. All right, guys, I want to talk to you about Phenyline Tank Shield. This lining is designed for the internals of tanks, valves, and pipes. It is good in a wide range of chemical commodities. It's good for potable water. It's good for fuels, oils, all of those services. It is incredibly great for. You get plural component performance out of a single egg product. That's huge, and it doesn't have any solvent in it. So that's the Phenyline Tank Shield, guys. You definitely need to check it out. So we talked about NSF 61, and you talked a little bit about NSF 600. How does that going to change the use of these systems? Do you see certain systems becoming more prevalent in the industry?
Yeah, most definitely. Because of this NSF 600 standard, it's going to limit some of the materials that you can use. And what that standard is doing is it's lowering the maximum limits for extractables for xylene, toluene, and ethyl benzene. So the significance of that is many of your, lower solids, I would say, or less than, I guess, probably 90% solids materials in a lot of cases are going to contain some variation of those solvents, if not several of them. And so, these would be the types of epoxies we've typically seen used in, say, ICS system 1, 2, 5, and 6. So, while there may be some different coating technologies that come out, maybe some different solvents used, for the most part, you're going to see any of those systems that utilize one of those types of epoxies, that usage is going to go way down. And in its place, you're going to see more of the ICS-3 and the ICS-4, which utilizes those 100% solids materials.
That's a great distinction and a great summary of where we're headed. Again, we've covered that NSF 600 in great detail, about 40 or 50 episodes back now. So as we move through this, what are some of the other considerations that you might think are worth mentioning for the inside of a water tank? Because that's what we're specific to today, is the insides.
Yeah, so there's some terminology I thought was kind of advantageous to bring up, but one of those would be, or actually two of those would be interior dry surfaces and interior wet. And so an interior dry surface, when you're thinking, especially an elevated water tank, these are going to be those interior surfaces of the fabricated structure that aren't necessarily exposed to the atmosphere or to the outside, or to the water itself in the tank or its vapor. So what this is going to be is things like the interior of the access tube, interior of the pedestal, and then even the underside of the tank bottom that may be within that pedestal. So in these instances, you don't necessarily need NSF 61 or NSF 600 just because it's not exposed to the water itself or the vapor of it. And so what you do see in some of these instances, though, is some sweating issues. So protective coatings are still needed, but sometimes you can use different systems there. But the interior wet surfaces in those areas, this is going to be, where you're actually exposed to the potable water, or even in the areas in the vapor, like say in the roof, where you may have the potential for something to condense and fall back down into the water supply. So these, like I said, are necessary to have the NSF designation there.
And if you've ever been inside one of these water tanks, and I'm sure, Brian, you have, and the amount of humidity and condensation and vapor that is in those dead spaces is obscene. It makes the swamps of Florida and Louisiana seem like nothing when you get up into those, especially when it's hot. There's just, it literally is dripping. So it is important to make sure that you have a system that's going to also still pass your NSF and your ANSI 61 standards for those spaces.
It's like you want me to go to HR. Anyway, in closing, what are some of the Carboline lining products that are used for potable water storage?
Yeah, so we have a pretty extensive list of those. So I'm really just going to point out a few, but I did want to point out that if you go to the Carboline website under markets, water, wastewater, we actually do have a pretty easy to use tool. It's lining systems for potable water. It's a pull down menu. It gives all the products and all their ratings. So it's pretty easy to view and access there. But talking about specific products and some of the ones that I see used quite a bit, and quite honestly, I see being used extensively into the future. First would be our phenyline tank shield. This would be our 100% solids epoxy option, NSF 61, 600 certified. This would be your ICS-3 type material that's used there. Absolutely. It's a thick film material, generally fast return to service, and it meets your VOC restrictions really nationwide. Yeah. So that would be one. I would say Reactamine 760 and 760 HB. That would be our polyurethane lining that would meet your ICS-4. This material, is going to meet NSF 61 and NSF 600. It's a ultra high build, can be applied at low temps, extremely fast cure to service. I mean, we're talking hours with this material. And then you also get, great tear, impact, and abrasion resistance out of this material. And then I would say lastly, you know, the one I wanted to highlight was our Carboline 635 VOC. So this would be a thinner film epoxy option, meets NSF 61 and 600. This is going to be a little, you know, an easy to apply material. Still is able to cure at lower temps, can be recoated pretty fast, and then meet some of your VOC restrictions because it's less than 250 grams per liter, which is going to meet a lot of the requirements across the country.
Well, excellent. I think that pretty much sums up a good coverage of AWWA D102 and the inside systems. If you want to go back, you can listen to our episode on the outside coating systems to get a full grasp and picture of AWWA D102. So Brian, thank you again for coming on.
And not a problem. And speaking of sequels, hopefully this one fits more in the category of The Empire Strikes Back rather than Grease 2. So.
Grease 2 went to the well for that one.
Boy, that was a
you?
deep one.
I mean, you couldn't do like Caddyshack 2 or Rocky 5 or
Dumb and Dumber.
Movies. I pretend that those movies don't exist. I think I've even talked about that on this show. But anyway, that's a whole other subject. We'll see you guys next week. Or we won't see you guys next week. We'll see you in 2 weeks. Later.